Hello everyone. So in this webinar, we'll be seeing the introduction of a real-time system as well as the structure of a typical real-time system. Now, what is a real-time system? How it gets differentiated with a normal embedded systems. So again, if it is going to be within a deadline, if it's going to be within a specified time, else it's going to be a doomed failure, then those systems can be summarized under the word called as real-time systems. So in a system with real-time constraint, again, it is of no good to have the correct action or the correct answer after a certain deadline. It should be completed within the deadline. So this is the typical components of real-time systems. So the algorithms for digital algorithms, the real-time clock, the interface engineering system. This is the database whereby it is used for data logging or data retrieval, a remote monitoring system, display devices, the operator's console and operator interface. So any system again which is going to be a timely response to the external input condition is a real-time system. It should be it should meet the deadline. The deadline can be odd or soft. That is, this is going to be maintained strict. It's called odd deadline. If some leverage is done, it's called a soft deadline. A complete task. So it should be estimated within the deadline. So all these discussions are there. So car and driver example is one simple example to understand real-time systems, embedded real-time systems. So it all depends upon the situation that the driver is using the car for driving. So if it's going to be a snowy situation, then if he's going to drive the car at 15 miles per hour and he's going to reach the destination safely, that's one simple instance. The other extreme case is going to be a bright sunlight and he's going to drive the car at 15 miles per hour and reach it safely. I cannot say it is a success. It all depends upon the mission, the objective. So that is one simple example that we can tell about embedded systems. Then so these deadlines, the formal specification, all these things are important. So regarding the issues in real-time computing, so the research areas cover computer architecture, fault tolerance, embedded systems, synchronization, all these things. uh, so for real-time systems, the deadlines are critical and high priority task is there. So this is the structure of a real-time system. Look here, all the jobs what I need to perform here are given to this particular processor. It will be triggered by a clock which is given here. The sensors are the inputs for the embedded system. So that is again collected and given to the execution. Once it is executed, the control process, it's called as actuators. It can be electrical device, electronic devices, electromechanical devices, the brake of a car. All these things comes under actuators. So it's given to the control process, the actual machine. The environment is a physical condition, and then so again it feeds your it controls this execution, the display and the operator. Suppose if you are driving the car, you are the operator. So this again controls this. So this is a typical example of the general block diagram I could say for a real-time system. Thank you.